Hey guys, the last one we're talking about is 7.7, which is the end of chapter 7. And just a quick reminder, in chapter 7 we learn a lot about the 6 trigonometric functions, like by definition and by identities. Also, we also learn about like reference angle, coterminal angles, and also periodic properties, even odd properties, right? And so many more properties in there. The last thing that we talked about was about like graphing, right? So I showed you guys how the graphs of the 6 trigonometric functions will look like, and also I told you guys a little bit about the domain range. So I'm gonna put it here for you guys to fill them out. Please try to not look back at the old notes and try to see if you remember those, because chances are they're gonna appear on your quiz and on your test. Okay, so it's just like something for there, so you guys can be aware of. All right, now let's talk about 8.1, right? The inverse sine, cosine, and tangent. We have like all 6 trig functions, but in here let's talk about like sine, cosine, and tangent first, and then on the next one, 8.2, or I don't remember, it could be like 8.3, we're gonna talk about the other 3 functions, which are cosecant, secant, and cotangent. Okay. All right, so just a little bit like like review for the old concepts. We have, if a function is 1-to-1, we have an inverse function. Okay, so this is like back in like algebra where we have like like the definition of function and the concept of being 1-to-1. If you want, you can look it up, but I'm not going to test you guys on this one. Okay, like I'm just putting it there so that it has some connection to the topic of inverse function that we having in 8.1, but I'm not going to test you guys on this concept of like 1-to-1 function or inverse function. I'm not going to test you like that hard, because they are like the things for algebra, not trig. Okay, so we also observed that if a function is not 1-to-1, it may be possible to restrict its domain so in some suitable manners, so that the restricted function can be 1-to-1. Okay, so what do I mean by that? Say I don't know, say if we have something like, I don't know, a parabola like this, and if you don't know what this function is, that's fine. I'm not going to test you guys on this again, because this is algebra, not trig. Okay, by the horizontal line test, if you want, you can look it up. We know that this is not a 1-to-1 function because it touches, like, say any like horizontal line that you put in there in some time, in some places among around, like this curve in here is gonna touches the red curve twice for here and here, for like this point here and this point here. Okay, so that's mean it's not a 1-to-1 function, right? But say if I want to make it 1-to-1, let's say I don't want to use like the whole curve of like the parabola, right? Let's say I only want like a half of it. Say let me put it in pink. Say I'm gonna like restrict the domain, and then I'm just gonna use the right brand. Like, just imagine like the full one is gonna look like this with the dash one, but I don't want the dash one, because if I include the dash one in there, I'm gonna have like a not 1-to-1 function, and that's not how I want it to be. Okay, so let me take this up away, and then in here, if you go for the horizontal line test, anywhere in here you will see that the horizontal line that you have only touches the function, the curve in here, once. So in here, this one is indeed a 1-to-1 function. Okay, and in here, in this case, we're gonna have like inverse, while this one does not have any inverse because it doesn't have like 1-to-1 property. Okay, so some properties of a 1-to-1 function f and its inverse function f inverse. Okay, symbol wise, this is f, the name of the function, and f to the -1, or in math we're going to say the inverse function of math, or f inverse is the inverse function of f. Okay, so some properties of them, I'm giving you like 3 of them. Okay, the first one, if you like substitute, if you like compose them one onto the other, then it's gonna return x. Okay, we're gonna see more of this property in the examples and in the next page. Okay, and also the next thing that we have in here is the domain and the range of the inverse function and the original function will be swapped. So the domain of f equals to the range of the inverse function, and the range of the original function equals to the domain of the inverse function. Okay, and lastly, like graphically, like in terms of graphing, the graph of f and the graph of f inverse are symmetric with respect to the line y equals to x. Okay, I'm not gonna ask you guys to like draw this thing, but you know, like just fun facts. Okay, so now let's move on to more reviews. So it's just a recap of, you know, like all the graphs that we learned from the last sections in chapter 7. Here they are, right? We have the graphs of sine, cosine, cosecant, secant, tangent, and cotangent, right? And again, these are periodic. That means that you can extend to both like the left hand side and the right hand side of the first cycle of each function, and in there you're gonna get more branches of them. Okay, you're gonna get more copies of them. Okay. And now let's talk about the very first objective of today. Find the exact value of inverse sine, cosine, and tangent functions. Okay, so notice that whatever in the box in here, I highly recommend you guys like print it out or like just write that somewhere and have it in front of you in terms of, you know, like the test or any assessment or even homework. They might be useful, okay? I mean, there's a reason why I box them instead of just writing them down, right? So these are important, okay? So by definition, if we have like an inverse function, that means that we're gonna like swap the x and the y, and if we swapping x and y, the inverse function will be gone. Okay, so originally we have y like alone, now we have x alone. Okay, and instead of having x on the inside, we have y on the inside. And as for like to compromise it, notice that there's an inverse function here while there's just like original sine function in here. Okay, so let me get rid of all of that because it covers your, you know, like your view. But just like by definition, make sure you remember one thing. Like the input in here is the output. Well, the output in here is the input in here. Okay? And then the input in here will be the output in there. Okay? So in terms of like restriction for x, we have from -1 to 1 because we talk about sine function. And in terms of y, we're gonna have from, let me put it in blue, we're gonna have from, you know, like negative pi over 2 or negative 90 to 90. Okay, and what else? So if you can't remember it, I'm gonna show you guys a quick trick to remember this in a second, and it will all make sense why we have it like this. For the reasoning why we must have it from negative 90 to 90 here, because okay, let me throw back to like the first page. Remember we were talking about sine function, right? So let's focus on this picture right here. For the first cycle, I told you guys we're gonna have like this junk in here, and then for the second cycle we're gonna have this, and if we open more and more, we're gonna have more, right? So then if you notice, like in each of the cycle, let's say if I only consider the very first cycle in here, if I draw like a horizontal line test in here, well, it doesn't pass this. Well, it doesn't pass the horizontal line test, right? Because it touches our sine function twice at here and here. Okay, so that means that we have to restrict the domain. Okay, like how do we restrict it? Well, the trick in here is that we're gonna go from like from this junk. Okay, let me just put in pink, from here to here. Okay, and why is that so? Because if you go for, you know, if you were to pick like from here to here, it doesn't have the bottom part, right? So everything must be positive. There's no fun with that, because everything in here would be like on top of the x-axis. That's not like fair for the things that go under the x-axis. And if you don't like it to be there, if you want it to be like between here and here, again, this is not fair because you only take care of the negative values. Everything would be like underneath the x-axis, which is not like good because we don't cover everything. So to be fair, we're gonna do something in between. Okay, we're gonna go from pi over 2 to 3 pi over 2. Okay, but as you can see, we cannot do it for like everything, right? For say for like pi over 2 and 3 pi over 2 in here, we're gonna get some asymptotes, right? And that will be like a problem. So to stick with it, I mean, like if you want, you can like go with pi over 2 to 3 pi over 2. That's fine too. But as a convention in math, we decided that for sine function, we're gonna go actually from negative pi over 2 to pi over 2. That means that we're not gonna have this one in there. Okay, and let me take care of like the cycle thing in here too. Okay, and that is how we have from negative 90 to 90 in here for sine. Okay, With a similar logic for a cosine function based on the behavior of the graph, we will decide that the y, it has to be from 0 to pi. Here, let me try to like highlight those out for you. And for sine and cosine, because if you remember, the range must be from, you know, like -1 to 1 inclusively, right? So we're talking about like the inverse function. That means that the domain in here would have to be from -1 to 1 because it's the inverse, okay? And then as for the range in here, for the y value, we're gonna have from 0 to pi by convention, just like a big like decision made by like the former mathematicians, okay? And then similarly, by the graphs also, we're gonna have tangent from -2 to pi/2 for the range. And then for the domain, we will go with -infinity to infinity, because if you remember, the range for the original tangent function, it covers everything on the y-axis, right? It has all the value. That means that the domain for the inverse function here, it will have to cover everything, okay? And my trick to remember this one, well, I'm going to mention it in the next page, but here, let me just put it here first. Just imagine if you're going to have like a x-y coordinate, right? We know that there are like 4 quadrants in here, and we know that this in here is like -90. Up here we have like 90, and here we get like 0, and here we get pi, right? So just remember one thing. For sine, is going to be, where is it? From -pi/2 to pi/2. That means we're going to have the first quadrant and the 4th quadrant, okay? And what does it mean? It means that you're gonna take from -pi/2 to like 90, right? You're not gonna have anything in here. Like this is a bad range. The other one is actually like a good range, okay? So that means that you can have something like less than 90 and greater than -90, but you cannot have something that's greater than 90 or less than -90, okay? So let me take this out the way before it gets to you guys, okay? And the orientation, well, the number will say it all, okay? So again, like say, if I give you some y value for the sine function, like, I don't know, like 100 degrees, and I'm asking you like, is it a part of the range? You will tell me no, okay? Because the 100 in here is way bigger than like 90, right? And we all know that because it's not between -90 to 90, 100 in here is not a part of the range of the inverse function for sine, okay? And then for cosine, we're gonna get also the first quadrant. So let me put it again in like green. And also the second quadrant, because we have it going from like 0 to pi. Okay, so as for my trick in there, let me put in red again. For sine, for tangent, it's gonna be either on the first quadrant or on the 4th quadrant. Okay, first or 4th. Well, for cosine function, we're gonna have it on either first quadrant or 2nd quadrant. Okay, and again, I promise you guys there will be like a clearer picture to show like the quadrant thingies in here for like all 3 of them. But I'm gonna show you guys that picture when we get like all 6 of them, so that you guys can remember everything at once. Okay, but for now, let's talk about the very first example in here. Find the exact value of this, right? Well, so you have the calculator with you, so you can do it like easily by putting it into your calculator. But of course, in the test, you will have to show me some work, right? You cannot just use your calculator and call it your work, because it's not your work, it's a calculator work, right? So how can we do this? Well, first of all, based on the definition that we have in here, we have to switch them, right? So let me think. Just imagine you want to find y, and you said, okay, let me put it in red again. Just imagine that you set the problem equals to y, okay, with the inverse in here, right? And by the definition that you have up here, what does this mean? It means that we're gonna swap in between x and y, and then we're changing the inverse to the original function, like this. And my x in here is actually like a valid number. It is -1, so let me just put a -1 in here, okay? So what did I just do, right? Like I just swap the inside and the outside, okay? And then to compromise that, instead of having the inverse function, I'm just gonna have a regular functions, okay? And now you have to look back at this chart in here, Okay, and then let me take out like some information before like everything got like confused. Okay, so we all know that sine here is the y value and x in here is the cosine value, right? And if you remember, like -1 in here, it should be one of the 4 quadrantal angle, right? So if you remember how to like draw them, okay, let me first draw a circle in here just to recall it. Let me take that out, and then up here we're gonna have a point of, what is it, 0 and 1. And down here we have 0 and -1. In here we have 1, 0. And in here we have -1 and 0, right? We're looking for some psi function that has the value of -1, right? That means that the y part equals to -1. And among these, only this one in here has the y part equals to -1. Okay? So the answer in here would be -pi/2. Okay, or if you don't want it to be -pi/2 radian, you can also put it as -90 degrees. Okay, but remember, usually I told you guys, like at this spot we're gonna have like 270, right? So why isn't it the answer, right? Why isn't it has to be like -90 instead of, you know, like having it positively as 270? Well, the reasoning for it is because of this like restriction in here. You must have something between -90 and 90 only, and unfortunately 270 doesn't match this requirement. 270 in here is way bigger than 90 degrees. Okay, that's why we're not gonna do 270s in there. And to get its coterminal angle, we're gonna take 270 minus 360, and it gives us -pi/2. Okay, so let me know if this makes sense. If it doesn't, I can, you know, like help you figure it out further. Okay, and then we're gonna do the same thing for this one in here. So next one, let me put it in pink so that it doesn't like confuse you with it. So originally I'm gonna set this equal to y, and then I'm gonna swap between the x and the y value again. So whatever inside will come out, and then on the function I'm gonna take out the inverse to compromise it, and then outside is gonna be inside. Okay, so now we're looking for a cosine value, which is like the x part in here that has the value of 1/2, right? So in the x-axis, where do we have 1/2, right? If you remember, like up here we have a 1, in here we have a -1, in here we have a 1, in here we have a -1, and in here we get a 0, right? So 1/2 on the x-axis, it must be something between 0 and 1, right? So it should be right here, right in between 1 and 0. Okay, so this is just about like the xy coordinate, right? It has nothing to do with the angle yet. Okay, so there's 2 ways to do this. If you know the unit circle well, you can look it up and find which one in there has the x part equals to 1/2, and the angle in here, it must satisfy this requirement of being between 0 and 180. Okay, if you too lazy to do that, if you don't have the unit circle with you right away, I will suggest doing with my way, which is like a little bit harder, but trust me, it's gonna be like super convenient and easy when you get a hang of it. Okay, so then you're gonna project it up here and down here, like project it all the way to the unit circle, and you're gonna get 2 points, right? And I told you guys that cosine has to be in between quotient 1 and quotient 2, right? So it means that it can be in here, it can be in here, right? But it cannot be in here. Okay, so that means that I'm gonna take out this dash in here, also that point in here. Okay, and I'm gonna go with this number up here on the top. And now, how do we know what angle it is, right? In here, this one, it's just like eyeball. To me, it looks like a 60. Why is that so? Because up here we know that this is like 90, right? And obviously it doesn't look like a 30, so it has to be like a 60. Okay, if you wonder like why it has to be either like 30 or 60, well, a part of it is because of the unit circle. If you have like something right in between, like right here, you will know for a fact that it's 45 degrees, right? Because it's like right in between 0 and 90 degrees. But if you have something like a little bit slightly like passing 45 degrees, it means that you must have 90 degrees, okay? And 90 degrees in radian conversion is going to be pi over 3. So the answer for this part will be pi over 3. Okay? So let me take these out. And then I'm going to carry on with the work for the last part on my example. Wait, come back. Okay, cool. So now for the very last example, let me do it in blue. I have tangent in here, and tangent is not like sine or cosine anymore, right? So that's like a harder thing to do. But hey, let me give you guys like a quick reminder of the trick that I told you guys, right? We have a table of like 30 degrees, 45 degrees, and 60 degrees, right? And I told you guys that if you label them, if you arrange them in the SOHCAHTOA manner, you're gonna have like sine up top and then cosine and tangent, right? And if you like do them with like numbering, you're gonna have like 1, 2, 3 in here, and then 3, 2, 1 in here, and then square it over everything, and then divided by 2. Same goes for like the second row. And then for the tangent, let me put it a little bit more on the bottom like this. Well, we're gonna take sine divided by cosine. Wait, I just realized that this one is supposed to be like over 2. Okay, so tangent in here is gonna look like square root of 3 over 3. This one is 1, and this one is just square root of 3, right? If you notice, square root of 3 over 3 appears right here for the 30 degrees, right? So first of all, let me do the setup for you guys. Let me take this out. So I'm gonna set this problem equals to y, and again I'm gonna interchange the x and the y part in here. So I'm gonna get something like square root of 3 divided by 3 equals to tangent of y. Okay, so now it's asking you tangent of what angle in here gives you square root of 3 over 3. And well, it's just right here, right? The answer is just right there already. So you can tell me that the answer in here is pi over 6 or 30 degrees, okay? And again, well, we always have that kind of like requirement to check, right? So you have to make sure that you have something between negative 90 to 90. But for like the tangent, you cannot have negative 90 and you cannot have 90, okay? So watch out for it, because in here, there's no dash underneath of the like less than sign, right? So it doesn't mean that you can take the two ends in here. But luckily enough, like the 30, it is in between negative 90 and 90, right? And it's like, obviously it's not negative 90 or it's not like 90. So this one to me is a good answer. Okay? So this one, just like, you have two ways to do it. First of all, first way, you can look at the unit circle and just tell me the angle. But of course you have to show some work, right? And that work will be like set it equal to y, and then interchange the x and y part. Make sure to compromise with that. You're gonna chop out the negative one for the inverse function, and after that, yeah, you just kind of have like look for the angle and just confirm that the angle works for the restriction in there. Okay, and let me put a green star before I forget. On your part, you're gonna have like ABC in here to do. Okay, and then this one is easy, and I promise you guys I'm not gonna test this on the I'm not gonna test you guys about this, okay? So this one, all you need to do is just like pull up your calculator, turn it on, and make sure you know how to set it to radians. If you don't, you just have to Google or like YouTube your calculator on like, you know, like on the internet, and try to figure out how to do how to set your mode in either radians or degrees, okay? And trust me, you want to figure that out soon, like as soon as you can. Probably like you can stop the video and then just go onto YouTube to figure out how to convert it in the calculator mode before we move on, because you're gonna need it for the test, also for like later pages too. So now if you have like everything with you already, this one is like straightforward. We have like each of these buttons on the calculator, so you just have to input them in, and then you're gonna get the answer, right? So there's not much of like explanation in here. That's why I'm just gonna go ahead and give you some sort of like the answers in here, and make sure you write like the unit in here, okay? Like don't drop out a unit, because like that would be sad if you drop out a unit. And this one is negative 1.56 radians, okay? And if you don't get these numbers, chances are you don't have it in radians. maybe you have it in degree mode, and this will change the answer, like totally change the answer. Even though your input is the same, it will change the answer like completely. Okay, so make sure you got that down. Okay. And as for the meaning of it, as for like what we have to like do, like what it means, like why do we have to learn this one, or like why are we doing this? Well, if you think about it, this one in here, it will be y first, and then you're going to interchange it. So we're going to get something like 0.98 equals to psi of y, right? And if you remember from like, you know, like back up the unit circle in here, for psi equals to 1, we're going to have this top in here, because this one is like 0 and 1, right? And the 1 in here is the y value, which is also the psi value in here. So this tells you guys that we're having something that's really close to 1. And if you like convert this to degrees, you're going to see that it's really close to 90 degrees, because like 1.37, let me see, if I convert it to back to degrees, what did I get? So 2 pi in here, and then 180 degrees, and then 1.37. What do I get for the other one? So, and again, I'm not going to test you guys on the work on this one, because like this one is just computer work, and I don't want you guys to spend way too much time for this one. But I'm just explaining it so that you guys know that it's there, okay? Okay, so it's going to give you something that's close to 90, okay? And then that's start for your part. And then let's move on to the third objective. So use properties of inverse functions to find exact values of certain composite functions. And I give you some like personal like advices or like hints in here. First of all, recall the domain range of the inverse sine, cosine, and tangent functions. What do I mean by this? I mean like the restriction that we had earlier. Like this kind of restriction right here. Let me like circle it in green so you guys know. Okay, just remember that sine and tangent, it has to be in either the first quadrant or the fourth one, while cosine, it has to be in the first quadrant or the second quadrant. Okay, so that's it about the sine and cosine. And then tangent about the domain range. For the second part, like from my personal advice in here, remember that like if you like compose the two function, the original function and the inverse function together, you're gonna end up having an x, okay? But the value for x will be different, okay? So in here, this x in here is actually a value. Why do I know that? Because like on the closest layer, we have the inverse function, right? And the input for the inverse function has to be a value strictly, okay? And then after that, like this whole thing will become the input of the psi function. And psi function only takes angle, okay? And after it takes an angle, it's gonna spit out a value. While for like the outer way, it's gonna spit out like, you know, like different layers and that. So keep in mind for this one, because I'm definitely will put it on the test, okay? I'm just gonna test you guys like which x in here is a value and which x in there is like an angle, okay? And number 3 in here, we call the concept of reference angle. So reference angle is a big idea. If you don't get it, please get it. Please ask me if you have any questions for that. Please don't waste like our time for spending like 7.4 for the whole week, right? I did it for a reason, and make sure you understand the reference angle like really well. Understand the concept of it, understand how to draw it, and understand how to calculate it, okay? And lastly, you always have to draw it out, like no matter what you have in there, as long as a function, as long as an angle, draw it out, okay? The original angle and the reference angle, okay? Draw them out. It will make more sense with the pictures, okay? And now let's talk about the work. So in here, well, my trick, usually it works, but then it doesn't work like all the time, right? Psi function and psi, they usually cancel them out like together. So the answer in here, it could be 3 pi over 2, right? But if you remember 3 pi over 2, it's actually 270 degrees if you convert them, right? And for psi function in here, I told you guys, for psi it has to be in between negative 90 and 90, right? And right after that, this is not in between negative 90 and 90, right? So instead of having like this angle right here, instead of having like 270 in there for going like forward, we're gonna go backward to get to the same point, but this time we're gonna get negative 90 degrees. And this is the answer because it's actually like fitting into the restriction in here. Okay, so again, this is not the answer. This is not the answer. The answer in here, it has to be negative pi over 2 or negative 9 degrees. Okay, let me box it to make it official. All right, and let me change the color for the next one. For the next one, again, you can use my trick. It's 1/2. If you remember the restriction for the value in here, and how do I know it's a value, not an angle, right? Usually the angle will have like pi to it, or like the degree symbol to it, but in this time it doesn't have a pi or any like symbol to it, right? That's like one reason, just by the appearance, why I know that the 1/2 in here is a value. Second reason, the input of inverse function, like whatever stands after the inverse function, it has to be a value, just like here. Okay, it has to be a value strictly. Okay, and now let's double check on the requirement that we have earlier for a cosine. Remember, for cosine, we must have something from -1 to 1, right? As for values, we must have something between -1 and 1 inclusively. Well, is 1/2 between -1 and 1? The answer is yes, right? So this one, it works. So we don't have to change anything. Like, that works already, right? So we don't have to change anything. We can call it the answer. So let me take out a circle and let me just box it instead to make it official. And lastly, we have the, let me put it in purple, tension and tension inverse. So my trick again, if you want, you can just, you know, like slash them out and call this an answer, but not too fast, right? We have to double check the restriction in there. If you want, you can scroll it back to like the page 3 if I'm not wrong. And the requirement for the angle in there, it has to be from -90 to 90, right? But this angle, if you convert it to degrees, let's see, what do I get in here? I'm gonna get 210 degrees. And you can see that 210 is not in here, right, at all. So let's draw it out to find where it is, right? So we have the coordinate in here. 210, it has to be a little bit, you know, like on the third quadrant because it's passing 180. So it's gonna be like somewhere right here. This is like 210. But, you know, since it's not like on the second quadrant, so what can we do for this, right? Well, how can we turn this into something that is, you know, like within quadrant 1 and quadrant 2? Let me think of like the way to explain this the best. Well, some of you might ask, like, can we use the trick that we used for like the last time, where we just go like backward and phi it? So if you go backward and phi it, this one in here, let me grab my calculator, 360 minus 210, it will give us like 150, right? And 150 is still not in the range that we want, right? So that method, it doesn't work anymore, at least for this case, right? So interesting. How can we do this? Well, in here, because this one is like tangent, right? So you can take my trick. You can look across to the other side of the circle, okay? So this one in here is 210 already. If you look across to the other side of the circle, it's like 180, right? So you can do something like 210 minus 180 equals to 30 degrees. And again, because I put it in like radian already, so let me put it back in like radian. The answer in here would be pi over 6. And the reason why I know this one is the answer is because 30 is indeed in between -90 and 60, -90 and 90, right? And if you ask me, why do I have to look across from, you know, the circle? Why do I have to take that value and minus it with 180? Well, I'm gonna remind you guys that for tangent, right, the period for tangent is pi. That's why if I go back pi, or if I go like pi furthermore, we will have like the same value because it's periodic. Okay. For sine and cosine, by the way, if you want, you can do the same thing, but the number you want to use in here is 2 pi, or like 360 degrees, because the period for sine and cosine is 360 or 2 pi, okay? So keep that in mind, and let me put a green star on your part. You're gonna have like ABC, like 3 things in here to do again. And the fourth one, find the inverse function of a trig function. Okay, so personal tips again, like I'm giving you some sort of like steps to do it. So in order to find the inverse function, we first proceed to solve for y, okay, and then apply the definition of the inverse function. I'm gonna show you guys in a minute what it means. It's something that we have like talked about in the previous like pages already, but don't worry if you guys don't get it now, okay? And lastly, this one is the big step and the easiest step in here. You have to interchange the x and y, okay? And another note before we get to the example is that recall that the domain of the f is the range of the inverse, and the range of the original function is the domain of the inverse function. Okay, so this is what I already put on the first page, but you will see why like right now in the next second. All right, and just a heads up, you will see this on the quiz. Okay, so pay attention to this one. Okay, so now let me just put it in red. So first step, solve for y, right? So how can I, well, first of all, where's my y, right? I don't even have a y in here. I'm gonna replace f of x with y, and that is my y. Okay, and then I don't do anything else. After replacing f of x with y, I'm just gonna copy everything else down, okay? And after that, I use the, apply the definition of the inverse. Well, what does that mean, right? It means that I'm gonna do something with the inverse. It means that I'm gonna do something with tangent inverse, right? But I cannot do it yet because like the tangent is not by itself. So I'm gonna solve for tangent first. Okay, so you know what, like instead of solving for y, actually solving for the trig function. How about that? Proceed to solve for the trig function. The trig function. That would make more sense. Okay, so I mean we have to solve for the tangent first, and in that sense we have to get rid of the -3, and at the same time we have to also get rid of the 2, right? So let me fast forward and then just like add 3 to both sides, and after that divide everything by 2. And again, this is like PEMDAS or like algebra. If you don't understand this one, please let me know so then I can explain this with you guys, okay? And now moving on to step 2. Now I'm gonna proceed to use the definition of inverse function. So remember that for inverse function, to pop out like the inverse function in here, we have to swap the input and the output, right? So that means that I'm gonna swap this and that. So whatever inside is gonna go outside, and whatever like on the outside is gonna go on the inside. And I'm spacing out a little bit behind the tangent because to compromise like that swapping procedure technique, I will have to put the -1 in here, and that is the definition of inverse function. It's swapping like the inside and the outside, okay? And last step, to call it like the inverse function, we would have to replace the x in here by f inverse of x, okay? And then for the inside, we're gonna replace the y in here by x, because it looks weird to have like a y inside of the function. So this is the complete answer that I want you guys to have in the quiz, okay? And now in terms of, you know, like staying in the domain range in here, what do we do, right? So the domain of f, let's look at this function right here. Let me put it in highlight. So this function is our f. What is the domain of tangent, right? If you remember from like the previous like section from like 7.7, the domain of f, it is all like everything except for, you know, like the odd integers, multiples of pi over 2. Okay, so you can say something like that. So you can say something like the domain of f equals to like all real numbers except for all the odd integer multiples of pi over 2. Okay, wait, this one is like a curly bracket. So there we go. And this one is my plus, a weird, ugly plus. Let me fix that real quick. Okay. Also, if you want, you can just say it in Word. You can just do something like, okay, let me scroll it up a little bit so that I have space here. Write it. Or, okay, let me put it in pink so that you can tell us the difference. Or another way to say the domain in here, it would be like all real numbers. Numbers except for the odd integer multiples of pi over 2 or 9 degrees. Okay, so this is for the domain, and as for the range, here, let me put it up here for the range of r, or the domain of the inverse function. You can think about it like both way, because we have this like right here already. So instead of having to find like the domain of the two functions, I mean, like if you look at this one in here, it looks way too ugly to even consider anything, right? So I would rather use the original function, and chances are this in here, it might be wrong, right? It doesn't like look right all the time, right? So let's stick with the original function if you want to find the domain of the inverse function. Just find the range of the original function instead, okay? If you remember, the range of tangent, it covers everything on the y-axis, right? So it means that we're going to have like from negative infinity all the way to infinity, okay? And another way to write this one is that you can say something like all real numbers. Like either way, either the red work or like the pink work in here, I'm gonna accept them both, okay? And this is your part in here. So just really quick before we move on in here is that make sure you fix the note in here. I think we have to change this in here. Instead of solving for y, we're gonna say something like solve for the trig function, just like what we did in here, so that we can apply the inverse function like definition, and then we proceed from there, okay? So make sure you change a note in here. I mean, it still makes sense-ish, but then just change it, okay? To make like more sense even. And now the last one, some equations involving inverse trig functions. Equations that contain inverse trig functions are called inverse trig functions. Like pretty straightforward, like, right? It has like the negative one in there. If it has like the inverse function in there, we call it the inverse trig functions. Okay, that's just like a little bit of a definition. I'm not gonna test you guys on that, okay? So don't worry at all. All right, straightforward. Again, we're gonna have work, and this is more like algebra, like PEMDAS thingy in there. So first of all, treat it like you have like a u in here instead of like wherever you have like the trig function. If you think it's too confusing for you, I'll just think of it like this way. You have like we have like 5 side inverse in here, and you have like another 2 side inverse in here, right? So to keep it like simple, let's just call u to be sine inverse of x, okay? And from there, the equation will become 5u minus 2 pi equals to 2u minus 3 pi, okay? Or if you're like not comfortable with it, you can even call x in here, but then notice that like we already have the x variable in here, so don't confuse yourself by, you know, like having x too many times in the problem. It's not going to end well, like from my experience. So I would suggest going with u or y, okay? Like those are the best variable that you can use. All right, so PEMDAS in here, because we have like some u's on the left and some u's on the right side, we will combine them. So I'm gonna like subtract a smaller number first, but if you don't want to, you can subtract like 5u from both sides. That works too, but then it's gonna give you like a negative number, which is, you know, like a little bit awkward. I'm gonna rewrite this. Okay, and again, we have like some pi's on the left hand side and some pi's on the right hand side, so I'm gonna combine them. Because like on the right hand side, we only have like one term, so I'm not gonna get rid of that term, but instead of that, I'm gonna get rid of the 2 pi in here, okay? But if you want, again, you can like add 3 pi's to both sides, but then keep in mind that there will be nothing left on the right hand side, which is, you know, like look awkward a little bit. And if you know how to deal with that, that's cool, that's great. If you're not good with your algebra, I would suggest that don't leave anything like, you know, just 0 on any side, okay? So this becomes 0, and we're going to get like 3u in here. And then -3 minus 1, if you put it into your calculator, you're going to get a -1, or like -1 pi, or negative pi in there. Okay? And lastly, to get u by itself, we're going to divide it by 3. And please don't stop in here. You have to substitute this back in, okay? A lot of people in the past, in my last semester, we stop in there and call this the answer, but this is not the answer, unfortunately, okay? Because the problem is asking you for x, not for u. We have to get x, not u, okay? So just because you get u, it doesn't mean that the problem stopped there, okay? Let's substitute u back for sine inverse of x. Okay, that is what we have for the left-hand side. On the right side, I'm going to keep it the same way. And whenever you have like the inverse 1 in here, let's apply the definition of the inverse function. So we will swap the inside and the outside stuff in here, and we're going to get sine of -pi/3 equals to x. Right, to compromise that, I'm going to like drop my -1 for the inverse function, okay? And if you remember this, if you put it into the calculator, you will get the answer. Or if you want to use a unit circle in there, that works too. So -pi/3, it is -60 if you convert it, and -60 is right here, right? It's -pi/3 or -60 in there, like either way that you want to call it. And we're talking about psi value, which is y value, right? So in here, the y value, I'm kind of projected toward the y, and this one to me it looks like a square root of 3/2. And because it's on the downside of the y-axis, this is negative. Okay, so this is the final answer. Okay, if you look like directly into the unit circle at the angle of -60 or -pi/3, you will see right away that it says something like, you know, like 1/2 and -square root 3/2. And if you remember the definition of psi, it should be the y part, and then you can like write out the answer right away, right? But if you're like too lazy to like remember everything on a unit circle, this is like my way to like recreate a unit circle, okay? And this is it. This is the final answer, okay? And as for your part, let me put a star in here, okay? And honestly, if you don't want to do it this way, you can do it another way, okay? Let me put like it in green, and let me use the next page for it. So first of all, let me copy that problem first. Like these two ways are similar to each other, but one way it doesn't have to like use substitution, and the other one you have to use substitution, okay? Like either way in the test, if you do one of the two, I will be fine with either one, okay? So you don't have to do two, of course, for the sake of time. But yeah, I'm not gonna judge you guys if you do the pink method or the red method, okay? This one is I'm not gonna use the U method again. I'm not gonna use substitution. I'm gonna go direct, okay? So I know that there will be some size on the left. I know that there will be some size on the right. So I'm gonna go ahead and I gather them together. So I'm gonna take this away. Also do the same thing for the left hand side. This is gone, and I'm having 3 sine inverse of x. Write down like -2 pi, and then writing down -3 pi, right? And same thing as before, I'm gonna add 2 pi to both sides. This is gone, and then this is 3, and then sine inverse of x, and then -pi, right? And to keep it short, I'm gonna divide both sides by 3 and take this away, right? And then by definition, I'm gonna get sine of -pi/3 equals to x, right? And just like before, we're gonna end up having the same answer as x equals to -pi/3/2. Either by looking at the unit circle, or like by my way of retracting the value from the unit circle. Okay, so this is the end of this section. Okay, so let me know if you have any questions, or you know, just take a screenshot and ask me if I confuse you guys at any moment of the lecture. Okay, thank you for your listening. Take care and have a great day. Bye bye.